Oh, hello, my dear students of class 10. Let's continue with organic chemistry. I hope the video sent to you is all seen properly, watched properly, and you have understood it. Okay, let's begin with today's topic, and today's topic is homologous series. Homologous series. Okay, homologous series. This series, so you know what is homo. Don't take it otherwise. This homo in science means same. Okay, same. So if you hear the name same, what does it mean? Same series means they come under the same. Means it's like a family, no? It's like a family. Same series. So actually, what is homologous series is there are many organic compounds, as I told you, 5 million and more counting. So out of these compounds, there are many compounds which have the same general formula and their chemical properties. Most of the properties are similar. Okay, so homologous series means this is a series in organic chemistry where different compounds are kept under the same column having similar properties, and they may have the similar structure. And also one most important point which has been asked in your ICC is they differ, the adjacent members in the same series differ by CH2 group. So let's take an example. Alkene. So we have discussed about alkene. And also alkyne. So from here only I would like to give you an example. So you have alkene with the 2 carbon is what? C2H6. 2 more than the double the number of carbon atom. Here C2H4, exactly the number of hydrogen is double. Recapitulation. Here it should be 2 less than the double. Double is 4. 2 less means 4 minus 2, C2H2. So this is the second member of this alkene series and alkyne series. Now look at the third member, C3H8, C3H double 6, 2 less than the double. C3H double is 6, 2 less is 4. You can see this one with 4, C4, 2 more than the double. Double is 8, 2 more means 10. C4 exactly double. So C4H8. Here it is. C4, 2 less than the double, 6. So I've taken 3 members of this. Alkene is one series, homologous series. Alkene is another homologous series. Alkyne is another homologous series. Now look at that. They all fulfill the general formula CnH2n plus 2. And this CnH2n, this CnH2n minus 2. You already know it. Now look at these 2 members. By how much it is differing? So you subtract the number of carbon atoms, okay? You can see C3 minus C2. Here 3 carbons minus 2 carbon. Will give you 1 carbon. 8 hydrogen atom. Subtract 6 hydrogen. How many hydrogens are left? C1H2. That means 1 you don't have to write. So each unit here it differs by CH2 unit. Here also you can take it. It comes out to be CH2. Here also you can take it. It comes out to be CH2. Here also you can take it. CH2. Here also you can take it. CH2. Here also CH2. So you have to remember this point, very important. Asked in ICSE, will be asked, might be asked. You have to know it that two nearby compounds in a homologous series, or two adjacent member of a homologous series differ by the unit CS2. CS2, here also CS2, 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 CS2. So these points are very important. Now, other properties are given. For that, refer to page number 187. Now, the most important, again, and the important topic is isomerism. And please, this topic has to be discussed now. So, isomerism, let's discuss about isomerism. Iso, same. Iso means same, no? Same molecular formula, but they will have different structures. So this is the definition of isomerism. So what is isomerism? Isomerism is the phenomenon by which same molecular formula can have two or more different structures. And these two structures with the same molecular formula, they are known as isomers, and the phenomenon by which these two isomers they exist is known as what? Isomerism. So if I give you an example, it will be more clear. So let's take butane. Butane, C4. If it is alkane, N, 2 more than the double, C4H10. Now this is the molecular formula. Okay, this is the molecular formula. Now, with this molecular formula, let's try to write the structure. How many different types of structures are possible? Okay, so one is simple. They have a straight chain C4, therefore 1, 2, 3, 4 carbons. Now try to fulfill the valency of each carbon. These are all hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each carbon's valence is fulfilled, and you can count 4 carbon atoms, and just now I counted there are 10 hydrogen atoms. So with this molecular formula we can have this structure. Okay, this structure is possible. So let's try to write, if it is possible, a different structure with the same molecular formula. So what would be that then? 1, 2, 3. Instead of in a straight chain, let's have a branch. Okay, so 1, 2, 3, 4 carbons. Let's fulfill its valency. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have to fulfill the tetravalency of each carbon atom. Please don't forget that. Now count the number of hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Any other structure possible? See, you might be thinking instead of this 1, 2, 3 and 4. This is also possible, but whether it is a straight chain or it's a straight chain, continuous chain, no? There is a continuous chain. So this compound and this compound will have the same name, or it's the same compound. Therefore, this and this is same. Now, what did you see? You saw with this molecular formula C4H10, I could write the first structure in a straight chain, another structure with the same molecular formula, but it's a branch chain. Now, these two, this compound and this compound, these two compounds are known as what? isomers. Why isomers? Because with the same molecular formula, but they have different structures. Okay, these two are isomers to each other, and the phenomenon by which these two exist is known as isomerism. So I hope this is clear. Isomerism, and this is known as chain isomerism. This is known as chain isomerism because there is a difference in the number of carbon in a continuous chain. 1, 2, 3, 4. Here in this case 1, 2, 3 are only continuous. If it comes this way, 1, 2, 3, you have to exclude this carbon, or 1, 2, 3, then you are not taking this carbon in your continuous chain. Therefore these two are known as what? Chain isomerism. In your syllabus you have chain isomerism and this functional isomerism. So let's discuss about functional isomerism in the next. It's not a functional isomerism, it's the position isomerism. Okay, the second one is position isomerism. So position means it has to do something with the position, no? Now let's take same formula. Say C4H8 now. This is alkene. Double bond has to be present. So C4, 1, 2, 3, 4. The other way you can write is 1, 2, 3 and 4. Okay? So in this case, suppose this is the counting 1, 2, 3, 4. 1, 2, 3, 4. Now in one case you can have a double bond between carbon number 1 and 2. Alkene has to have a double bond between this, or in the second case you can have the double bond between the carbon number 2 and 3. So there is a change in position, no? Now try to fulfill its valency. 1, 2, 3, 4, 5, 6, 7, 8. So you can have this structure, or you can also have this structure. 1, 2, 3, 4, 5, 6, 7, 8. So in these two compounds, with the same molecular formula, you can have this structure or the second structure, isomers of each other. Now whenever you consider what type of isomerism is this, then you have to see the position. Okay, here the bond between the double bond is between the first structure, it's between carbon number 1 and carbon number 2, and in the second structure you saw the double bond is present between carbon number 2 and carbon number 3. So there is a difference in the position of what? The double bond. Therefore it's known as what? Position isomerism. Okay, so in your syllabus you have only these two types of isomerism. In class 11 you learn more types of isomerism if you happen to take chemistry. So in the next class we will be beginning with the IUPAC nomenclature. Okay, so till then, this class video and the previous class video, it has to be well understood. Thank you.